So in this tutorial, we're just going to look at the very basics of sequences. There are other tutorials which deal with the more complicated bits. But the first thing we're going to do is decide what a sequence is. And in mathematics, a sequence is simply an ordered set. And for what you're doing, it's usually of numbers. So it is an ordered, in other words, there is some order implied, an ordered set of numbers. Okay, and then you have two sorts of rules to generate a sequence. You either have a position to term rule, which gives you a formula for the nth term in terms of that letter n, which is just the position of the term, and we'll look at those in a minute, and a term to term rule, which gives the n plus 1th term in terms of the nth term. So if you know one term, you can find the next term from it. Okay, and if it's going to use any fancy notation, it'll call the nth term an and the next term an plus 1, like that. And then there are a few sorts of sequences you need to be aware of, and their names are linear, quadratic, geometric, Fibonacci, but you'll be told how those work, and there are other ones as well. Now, there are tutorials on all of those, so we'll just have a quick look at a couple of questions. So in these questions, we're given an nth term and we're asked to find some particular terms, okay? In each case, the first 5 terms. So I'm just making a little table here of n and the nth term, and all I do to find the nth term is I put n, in the first case 1, into there. So 3 times 1 plus 4 is 7. And in the second one, I just put 2 into there. So 3 times 2 plus 4 is 10. And then I do, unsurprisingly, 3 times 3 plus 4, which is 13. And then 3 times 4 plus 4 is going to be 16. And 3 times 5 plus 4 is 19. And we have generated the first 5 terms of the sequence. And if I do that again for the next one, again, we just put in the n. Okay, so n equals 1 goes into there. 1 squared is 1, minus 1 is 0. And again, 2 squared is 4, minus 1 is 3. 3 squared, so we're doing this one now. 3 squared is 9, minus 1 is 8. 4 squared is 16, minus 1 is 15. And 5 squared is 25, minus 1 is 24. Just so you are aware, this first sequence is a linear sequence because that is a linear expression. This is a quadratic expression, and so this is a quadratic sequence. Okay, now what about this last one here? This time we're given the nth term is something strange. N over n plus 1. Okay, well let's just try that. So the first one is 1, that's n, over 1 more than n, which is 2. The second one, 2 over 2 plus 1, which is 3. 3 over 3 plus 1, which is 4, and you get the idea, 4 over 5, and 5 over 6. And you might call this an other sort of sequence because it doesn't fit any of the other ones. Let's look at term-to-term rules now. So in this case, we're given the first term or 2, and we're asked to find the next 4 terms of these sequences. Okay, so the first one, we start with a1 equals 3, so a2 is equal to 3 plus 4, which is 7. a3 will be equal to 7 plus 4, which is 11. Notice each time what I'm doing is I'm taking a2 is a1 plus 4, so I'm adding 4 to the next term. To get the next term, a3, I take a2, which was 7, and add 4. And so a4, I'm going to take a3, which is 11, and add 4, which is 15. And a5 will be a4, so that's 15, plus 4, which is 19. And there are the next 4 terms. Okay, that's also a linear sequence. Now, this next one, we're multiplying. So A2 is going to be 4 times A1. So 4 times 2 is 8. A3 will be 4 times A2. A2 is 8, so that'll be 32. A4 will be 4 times A3, and 4 32s are 128. And A5 will be 4 times A4, which is 128, and 4 128s are 512. And for your information, this is a geometric sequence. Go and have a look at the tutorial on that. And then this last one, well, look at this. This is a bit different. To find an plus 2, we take an plus 1 and add an. And this is, in fact, a Fibonacci sequence. Okay, because you take 2 terms and add those together. So that A3 is A2 plus A1, and we're given those over here. They are both 1. So A3 will be equal to 2. A4 will be equal to A3, which is 2, plus A2, which is 1. A5 will be A4, which is 3, plus A3, which is 2. So that's 5. And A6 will be A5, which is 5, plus A4, which is 3. And there is the beginning of the standard Fibonacci sequence. These numbers here, 1, 1, 2, 3, 5, 8. It would go on, 13, 21, etc. And that's a quick introduction to sequences. For more complicated stuff, have a look at the other tutorials.